Hurley, welcome to Stories in AI. How are you today?
I am doing well. It's good to see you again. I think it's been a few years since we've chatted.
It's been a long time, and I've been looking forward to this conversation. And why don't we get started with who is Whirley? And tell me your story, your backstory, and how you got into what you're doing right now. The whole game.
Man, that guy is a bum. Do we have to talk about him? No, I'm just kidding. No, look. I think at this point I've told this story a lot. So started in a band, got in a bad accident. Band moved on without me. Ended up answering phones at Apple Computer in the early '90s, around '93, '94. Worked my way through managing training programs and R&D, and then left there for IBM in 1997. Spent 2000 to 2009 bouncing between big companies and startups, listening to big companies talk about all the problems with startups, and startups talk about all the big problems at big companies, and decided there could be a blended model, and started my first startup called Chaotic Moon in March of 2010. And that went well and sold to Accenture. We had a spin out that was sold to Zynga. And then in 2015, I did, my second or third, depending on how you want to count it, startup in the retirement savings space, because we have one marketable skill. We write really good software. It doesn't matter what it is. That's our talent. And so that was acquired by Goldman Sachs on its first 1 year anniversary, which was astounding.
That was awesome.
Story that'll probably never happen again in a million years. And needed something to do that was bigger, that was better. And I had biohacking, robotics, and quantum on my little what could be next planner that I keep and I update every 6 months. And robots, they're not here yet. You see how many times Boston Dynamics has been sold and traded hands and
Yeah.
everything. But biohacking, obviously going to be heavily federally regulated. I just got out of a regulated industry. I was not looking forward to
thrilled
spending the
about it.
majority of the money on that. Yeah. And I looked at quantum and I looked at my kids and I thought, about the environment, and I thought about diseases, and I thought about all of these things. And I thought, this is something that I'm not going to win a Nobel Prize for some discovery. I'm not going to write the next greatest algorithm or whatever, but we're really really well positioned as a team to write the software on which other people can build those tools and other people can do these world changing things. And I thought that'll be our little part in contributing. And we started as a Linux Foundation project. Didn't get a lot of support. A lot of the industry at the time was, they're going to be the one that owns everything.
Yeah.
And my friends, I said, what are you going to do? I said, well, we're going to start another company. And got the same group of guys and gals together, and we're starting again, except this time with about a 20-year plan that we're about 5 years into. So we're about a quarter into our plan for how we want to build the company. We're still smaller than everybody in the industry, right? There's 15 of us. We only took $4 million in our initial funding, so we haven't raised hundreds of millions of dollars. But we know how to build and scale startups and build and scale software. And we're just sitting here doing our own thing on our own timeline, and hopefully starting to help a lot of people out there get into quantum, get it more accessible, get it more inclusive. Because our first slogan was humanizing quantum, so that was kind of the idea. There was to kind of quantum for all the people, if you will.
That's awesome. I think fascinating background. By the way, I think the part that the audience will probably read about if you actually Google Whirley and Austin, right? Keep Austin Whirley is what I think it was. Who said that? Was it? Um,
I, I don't remember. I think it was Bob Metcalf or Hugh
or it
Forrest.
was Hugh
I,
Forrest,
I,
I
I
think.
think it was you, which is wow. Okay, thanks, you.
Right,
No
coming
pressure,
from the
right?
guy who puts together South by Southwest, that's a
Right?
pretty
Yeah,
amazing thing, right? So
yeah.
there's so much, and then just like there's so much color in your background and your, not literally, but I'm saying just there's so much richness in this thing, and it's an amazing mission you're on to humanize quantum, making this powerful, really nebulous technology accessible to everybody. So talk about that. Let's start with quantum. What the hell is quantum computing, and why should we all care?
Well, so, my personal opinion, and I'm assuming most of the audience may not know. And so I've got my handy dandy coin, right? No sleight of hand tricks. I could try to make it, but I'd suck. Um, think of classical computing, the iPhone, your Android phone, all the way to create a supercomputer, being like this coin, having a heads, this blue side, and tails, this white side. If I put it in my hand, tails up. If I flip it over, it's heads up. So this is a one, that is a zero, and in that two-dimensional plane it can only be those things. I take the same coin, I flip it in the air, and when it's at the apex of that spin, is it a tails or is it a heads? And the answer is it's in a quantum superposition of some probability of one or zero. Much like a coin toss, until I catch it and I measure it and collapse that state, I don't know if it's a one or a zero.
Hmm.
Why is that? Why is that important that it's probabilistic? It's important because if I have 4 bits rather, I have 16 outcomes. I can be in any one of those outcomes at one moment in time. But if I have 4 qubits, I still have 16 outcomes, but I can be in all of those outcomes simultaneously in this quantum world. And so obviously that means the power curve grows exponentially. Unlike a bit where I have 4 and I add 5, and now I go from 16 to 25. Now I have 4 and I add 5 and I have 2 to the n, the number of bits, right? So everything increases exponentially, and it's you're getting into things like polynomial speed ups and things like that, and it's really super valuable because let's face where we are with computers. We kind of stopped with the supercomputing and started building Facebooks and Instagrams and TikToks, and we're not really doing any really exciting stuff to make the world a better place. As a tech industry for quite a while, there's been a few projects, but now we're seeing more SpaceX's, right? We're seeing more, we want to go to Mars and we want to cure cancers and we want to do stuff. Well, we don't have the compute power to do it. It's not that classical computers couldn't do it. It's that a classical computer, the evaluation time for it to do it might take tens of thousands or hundreds of thousands or millions or hundreds of millions of years. And so we need a different form of computing to help us get to those answers. But they go together, right? There's not a classical versus quantum. I know a lot of people in quantum are starting to call classical vintage computing, which I think is obvious slam. But vintage computing isn't going anywhere, and you're not going to have a quantum processor in your phone anytime soon. So this is something you want to look at. I compare it to trains and airplanes. You used to cross the continental United States from New York to San Francisco. The journey took months. Maybe somebody died. Who knows? They could have gotten eaten. Whatever. It was weird. Now you got a train system. It takes about a week, and it's safe, and you can use bathroom on the train. All this good stuff. Well, no matter how far you go, you eventually reach an ocean. So think of that ocean as the ocean of computational complexity that we're facing right now in life sciences and material sciences and things of that nature, energy products and new forms of
Yeah.
energy, right? And so what do we have? We have planes. So you don't take a train from Austin to Japan, right? You take a plane. But you
Yeah.
can take a train in Austin. You can still take a train in Japan, right? We didn't get rid of them. So think of quantum computing as this augment of classical computing
Yeah.
that is the first in a series of new exotic computing technologies. I believe you'll see quantum, you'll see different types of neuromorphic. We're going to talk, I'm sure, about ML and AI and QML and all of that stuff. All of these things will start creating new forms of computing. Eventually, you'll have DNA-based storage, DNA-based computers, things of this, as we move closer and closer to nature. So you look at it and you say, look, we split the atom to destroy, we split the atom to create energy, and now we're splitting the atom to create computational power, right? That is a way oversimplified, and physicists everywhere just cringed when I said that. But I think that's a fair way to look at it, in my opinion.
Interesting. So let me break this down, right? So you're it's the quantum computing is a new way of actually solving problems. It gives you the superpowers of speed, being able to represent data in a slightly different format in a way that you can compute faster, more efficiently than having to burn all of things. So as a result, you can actually
Well,
get to results quicker.
Well, think of that plane train example,
Mhm.
right? So trains can't fly, right? So is a plane faster than a train? Yeah, but is that also a fair comparison to say,
Fair.
to compare plane? So when you think about classical versus quantum, maybe think of it different. It's not going to make the cat video on the internet faster, but if we took the classical traveling salesperson problem, Michelle Simmons, I think is probably the first person to use it. A lot of people have used it. I use it as well.
Yeah.
But when you look at it, say we want to go to 14 cities with the most optimized path. Okay, my laptop will do that in a few thousand seconds. Okay, go from 14 to 22, a difference of only 8. That same laptop takes a few thousand years. Go to 28, 30, 40 cities, it takes longer than the time of the known universe, right? So it's faster, but we have to change the way that we talk about and the way that we perceive speed. And I'll give you a link for an article, but a couple of years ago, because I was very frustrated with everybody, um, that was basically, oh, they're faster. It's going to crush encryption. It's going to do that, all of this. I wrote a tech piece, a TechCrunch article called "Stop Limiting Quantum Computing to Speed," where I talked about like how you should think about it.
Yeah.
Yes, it's faster. It's faster, but it's like saying, "Wow, the SpaceX BFG is going to be so much faster than my '94 Corolla," and it's like, right, but you shouldn't compare those things.
No, that's fair. That's fair. On the one hand, definitely it's fair. But what I'm also trying to understand, what you're saying is, it is a best fit for a class of problems that otherwise would be
Mhm.
really hard to solve. Like, totally see
It
that.
is a, it is whether people want it or not. It should probably be looked at as a special purpose device. It's a special. We got different forms of calculators, and we have this new form of computational science, and it does these things really, really well that other things that we currently have don't allow us to do, or don't allow us to do in any kind of time that would be,
Sure. But
into any kind of scale.
But isn't that also a point in time point of view, right? Meaning, like, if let's say everybody
Sure.
does their job well, and this becomes the form, like we were completely satisfied with, our the cable modems and
Yeah,
your cell phone modems, if you will, browsing the internet. I click on
that's right.
hotmail.com and wait for 15 minutes and was okay with that. Not anymore, right?
Yeah.
So
Yeah, but you have to think about, this gets into the paradox of computational advancement,
mm,
meaning, we all know the story about the IBM CEO saying, "I think there's a market for at least four computers in the entire world," or whatever thing he said. And it's fun to look back and say, "Wow, that guy really lacked vision." With the benefit of hindsight, right? Like it's so easy to do that, but what you're hitting on falls less. It is a moment in time. And it's a very important moment in time. And the area I would stress you to focus on is not what we were just talking about from the moment of time view, but from the following. 1963, the integrated circuit is starting to take off. Invented in 1959 by Jack Kilby. Jack Kilby made the integrated circuit. Why? Because before that, you bought transistors one at a time to
mm,
build anything. You'd be like, I need 12 transistors, right? So integrated circuit kind of started the modern day information revolution, started the stuff we're doing. So think of it as a moment in time, but don't think about the speed thing or the usage thing. Think about its impact on humanity, right?
mm,
I don't care about using a quantum computer to do a quantum Monte Carlo for a finance company or for better drug discovery. I don't want better drug discovery. I want to eliminate disease. I don't
yeah,
want better battery chemistry. I want completely new forms of travel we've never dreamed of. And so if you look at 1963 and you think nobody was looking at autonomous cars or AI or any of the things that we're going to talk about in this call, and that wasn't that long ago, right? I mean, it seems like a long time ago,
it
but
wasn't that
really,
long ago. Yeah.
the grand scale of things, it was a blink of the eye. Now look at 2023 and say, I believe 2023 is the starting gun for yet another revolution. So industrial age, information age, quantum age. And so now, the excitement isn't is it faster than a classical computer at doing a thing? That's a stupid,
Way to think about
argument to have. The way to talk about it is there are a bunch of things it's capable of that nothing we've ever had in our computational arsenal could even remotely do. What are all the amazing things people like you and people listening to this are going to imagine and build? They're going to change the world further than we could ever imagine. Because if you just went back 10, 15 years ago, 20 years ago, think of all the technologies we have now that weren't here, and
it. Yep.
then think of all the technologies that we were dependent upon that no longer exist.
Yeah. No, no, I
20
totally.
20 20 years ago, you still had CDs
Yep.
and you loved them and you were buying them up, right?
That's
I
true.
mean, so maybe a better perspective is to think about it for that the speed doesn't matter is my point.
Yep.
What matters is the capability,
Yep.
right? We shouldn't be talking about speed. We should be talking about computationally what can it do that we've never thought of doing
The
before.
complexity
Dreaming of
of
all kinds of
problems,
stuff.
the scale of problems, the complexity
Sure.
of problems, and so forth. So that break that down for me a little bit. Like, give me some examples of these class of problems, and also explore why it's not possible to solve that with everything that we have in our computational arsenal. You made that
So
example of
look,
us having
that's a great
Hurley problem, right?
look. There's a bunch of great examples. Let's take it back a step for our audience and think about this. Um, you can talk about, NP, NP plus R, BQP, all these stuff,
Yeah.
or you can frame it in the context of this. Computers have done us really, really right
Yeah.
for the last,
Yeah.
since like the Apollo mission, right?
Yeah.
Everybody likes to take their phone and say, this phone is more powerful than what we landed on the moon with, right?
Yeah.
And now we have insane computational power. We have insane algorithms that can run over data. We're producing more data every second that we're on this. I mean, think of this recording and how many gigabytes this recording is going to be, and then go back 10 years at the size of an average hard drive. Now go back 20 years and think like you would have been filling up a supercomputer 20 years ago, right? Or something,
Easily.
right?
Yeah.
I mean, probably not that much, right? That's an obvious exaggeration, but think about things in perspective. So now think about, okay, what do these problems look like? What does a practical application look like? Life sciences, oh my gosh, there's so many opportunities.
Yeah.
Material sciences. Elon wants to go to Mars. I don't think he's going to finish the journey without using some quantum computer in some way, right? You want to have autonomous vehicles everywhere. How are you going to come up with all of the probabilities of routing them and the traffic and all the things, So it's just it's a new area, and I hate that we're calling classical classic and quantum
Amen.
quantum. It should be there should be a. I've heard advanced compute, non-traditional compute, next gen. I think of it as exotic computing. And I think if you don't think the physics of a quantum computer are exotic, then you're crazy, right? Because
Yeah.
it seems really exotic to me when I'm
It
looking at them.
is.
But you want to say, okay, what do we apply this for? What's a practical real world example? Like Volkswagen's been using this to do autonomous vehicle routing. Uh, you know, uh, Frankfurt Airport's been using it to route 170,000 passengers across 280 gates every 24 hours. Are they dependent upon it? Is it running all the time? No, and it doesn't have to. Stop trying to make quantum computers work like classical computers, right? If there was one quote I could have people remember, it would be like, stop trying to take your ideas. Think of this like, we just got this new amazing technology delivered right into the palm of our hand, and it's coming, okay? And let's say that it's 1963 and I have an iPhone, right? And I'm like, man, this thing is the greatest camera ever. Or I'm like, this holds the window exactly 6 inches open and the breeze is amazing. That's how I see people trying to use quantum computers
Yeah.
today.
Yeah.
It's like, right, but does that thing connected to the internet? There's like an infinite amount of information. And, oh, by the way, you could do insane calculations on this thing, and et cetera, et cetera. Like, stop trying to limit what quantum computing represents the future of humanity. It represents fixing this planet before we leave it. It represents taking care of water and food supply issues potentially. Think of the chemical composition of fertilizer, how much we could improve on fertilization products, which will grow more food in areas maybe where people don't have enough food. Think of those kind of things. Like if you want examples, that's the kind of thing I'm thinking about, like fertilizer chemistry for agriculture, thinking about new drug discovery. No, I'm thinking about how to use things like CRISPR and find out what you could actually put into somebody and now they don't have a disease. Maybe there's some things we don't know that could be reversed. I mean, how mind blowing would it be for you to see some doctor somewhere, thanks to a quantum algorithm, have been able to find some sort of molecular bond, and they use something like CRISPR, and they fix somebody that has a thing that otherwise is completely debilitating. How much does that change the world? How much does food supply change the world? How much does the environment change the world? Right? This is what we should be focused on. And the class of problems, I don't think we've identified yet. Because while we might be able to take those problems and relate them to, oh, it's like an NP or NP plus R to this, that, there's a delineation point in quantum where it becomes real. And everything after it is the wild, wild west, in my opinion. It's like 1963. It's like the 70s. It's like the homebrew compute club. It's like the days of the mainframe where Cray was like, man, we're going to use this for science, right? Or, all this. This is we're about to hit the biggest reset button in the history of computing, and everybody's treating it like an opportunity to go make some money at a startup, or win a Nobel Prize, or do this or that, and they're missing the big picture, which is the entire world as you know it is about to change forever, and how it changes depends on how much we're paying attention and what we're doing with that technology right now, in my opinion. It's a
No, it's
super,
fascinating.
super opinionated stance. Sorry.
No, but it's very. I mean, the one thing I really appreciate you spending the time to stress on is the fact that this is where this is going to change everything, and the fact that you should think about it less about another leap in compute power and more in terms of an opportunity to solve some of the unsolved problems that humankind has ever had.
That's
Right?
right. That's
Um,
that's right.
why haven't we solved it so far, and what's different today, and what needs to happen for this to be successful?
Well, look, there's a million reasons we haven't solved a lot of problems, right? There's geopolitical problems, right? There's cultural problems. There's all of these different divides. But if you look at it from a purely computational standpoint, there are a whole new class of problems awaiting to advance scientific discovery, and these problems are not uh, solvable with the current tool set we have. It'd be the equivalent of me going back to when the abacus was the leading computer on Earth and being like, hey, let me tell you about the human genome, right? So if you have 1 billion of these devices, I could kind of right? It's a capability
Yeah,
problem,
yeah,
right? It's just a new form. And think about the internet. When we had the internet, how it exploded, how many things, and
yep,
now you've got all of these different the same things that have come out of quantum information science, not just in computing, but in sensors, in all the stuff that they
in the
want to
way
do
you
with
think about the
cryptography.
problem solving. Yeah,
Quantum information science is going to bring a whole new. It heralds a whole new age, and I just see too many people looking at it as like, well, we're going to build this new thing that does this thing that other people already do. We're going to sell it, and then we're rich. And it's like you're missing the entire point
yeah.
of being involved in quantum computing.
So if we believe in the mission, the big um, opportunity to completely, hit that reset button and solve problems that we never even imagined that we could solve, it also means that there is an ecosystem of capabilities that needs to be developed, right? Everything from being able to build a quantum computer to understanding how to think about these problems to translating our knowledge that we have in classical world to a quantum world. And just this is not just like one flip switch and it's going to happen, right? Like you said.
No, no, it's not. But look, putting more money into a project doesn't make it go faster.
Yeah.
Putting more people on a project doesn't necessarily make it go faster. But when it comes to the brainstorm of scientific discovery, the first step, the what ifs,
Hmm.
the more people we have putting inputs into what ifs,
Got it.
right, the better. And so, look, we still don't teach basic computer science in a lot of the schools around the world.
Yep.
Okay. And we
Right.
barely teach maths and core stuff. And so what I'm saying is this extends beyond it. What do we need to be thinking of? We need to be thinking of, and I always joke about it, but like we wrote quantum computing for babies for a
I have
reason.
that. Yeah, I
I,
have
I
that.
know, but we wrote this for a reason, and part of the reason that we wrote that is extremely important that we start. And it was yes, it was kind of done in fun, but there's a serious message behind it, which is like we need quantum information science taught in high schools here in the states and worldwide. We need physics taught more in middle schools. We need more CS stuff taught, and we really you think of the talent shortage we had at the beginning of kind of the information age. How many people knew how to use a computer or just Excel or whatever? And now
So
you amplify that dramatically and you say, oh, by the way, this could be what saves the planet from extinction. So it sounds more important than Excel. So maybe we should be spread that knowledge around and
pay
getting a lot more
attention to
people
that, right?
involved. Yeah.
It's interesting. It's like you said, like 15 years from now, 20 years from now, you'll look back at this moment saying, duh, it was stupid for us to not to pay attention to it, right? So,
That's
make
right.
make this real for me and for the audience, right? One, why, where is the industry today? What can you do with quantum computing capabilities
It's a
that are
great,
there,
great
right?
question.
And then two, again, you kind of answered why should you pay attention. The question that I have is like, what should they do right now with where the
That
market is,
that
right?
two awesome, great questions. So your first question is like, okay, what can you do? So I'll tell you a little story. When we started Strangeworks, I used to say we write software for computers that don't exist. And I think I will hold, no matter what any physicist in the world or any computer science says, I will hold true that if you go back 5 years, they weren't even close to being computers, right? Um, and there's an argument that they were, and blah blah blah. But
Sure, sure.
I'm not buying that. So then you fast forward a couple of years into the kind of life cycle of Strangeworks. I had to change that. Say, well, they're not computers. They're more like really good equipment for exploring the quantum landscape because they made a lot. I mean, when we started, you're talking about 7 to 17 qubits. 2 years later, you're talking about 127. Next year, IBM will announce an 1100 qubit machine. So where is it today? Today, is it in the perfect place? I believe that the starting gun for quantum is 2023. At some point during that year, you are going to see a much bigger uptake in quantum. Here's the other thing I believe. I believe any of us are ready for it in the way that we should be. And so what can we do to start getting ready for this? You
Mm.
have to start looking at your organization, looking at yourself, your career path, whatever it may be, your research group, and saying, where can we take advantage of quantum in new ways and build an attack vector out to some point, 2 or 3 years in the future, and start planning now, because it's going to take you 12 to 24 months to get a team, to get them together, to get them even remotely doing anything productive. This is what we've seen over thousands of people. Like, you can't take a software developer and boom, they do quantum. I wish they could. That was one of my original goals, but it's just not possible. So what can you do with them today? Look, you can obviously do a lot of good optimization work, okay? And let's also be honest. You can run a QAOA on classical. You can run a VQE on classical, right? You don't have to have quantum do them. But there are some advantages. I think of John Preskel's, because this is the AI,
Yeah.
podcast, right? I think of John Preskel's paper from December with the team that showed, I think they did 1,300 experiments, I think, on 40 superconducting qubits, and they showed an actual advantage, a documentable, verifiable advantage. So the machines are now at a point where you can start discovering the things that we can do. Previously, I think, there was enough stability and coherence times and things like that for you to do that. So we're still in the infancy, but think about this. IBM gets to 1100 qubits. I think they'll be able to start solving using qubits some of the problems with qubits, right? Like,
Yeah.
and so I think you're going to see that go up. And I think you see that reflected in their roadmap and other companies' roadmaps. Look at IBM's roadmap. It didn't say we go from 127 to 433 to 1100 to 5000. It said somewhere between 1100 and a million, right? If you look at their roadmap, the last part of it's like, whoa, could be 500,000. Don't know. And I think that's because, the team over there sees the same thing. I think the team at Rigetti sees this. I think the team at INQ sees this, at IQM and Cold Quant and Atom. I think this is among hardware people, a general thing that they're like, look, we're on the precipice of this kind of watershed moment in quantum.
Yeah, no, so that's amazing, and I think it's you've laid out the roadmap for leaders what they have to start doing today, right? I mean, I have two questions. One of them I'm going to probably do as a follow up and add it to the show notes is like, where do they learn more? How do they start today? Right, that's number one. But then I want to actually touch upon the intersection of machine learning and quantum, right? In the remaining time that we have, right? Talk a little bit about like, what does it mean for current machine learning practitioners? And also, is it like, better tools, different kinds of tools to go solve the same problems you're solving? Is it back to original argument that everybody talks about, more horsepower to the problems that you would otherwise solve? Lay
Right.
that landscape out for me.
Well, obviously, quantum's not appropriate for everything. However, in machine learning, like I said, you've got the John Preskel paper I just mentioned. You have
Yep.
several papers that you can go look at the archive and say, wow, there's really interesting stuff done in QML. There's obviously an advantage in models to me because of the fact of the probability factor, right? So I think, if you're in machine learning, you should be working with quantum like today. Does that mean it's your job immediately? No. Does it mean it's some big pay raise? Does it mean no? But I'm telling you, in the next 12 to 16 months, you'll see those two worlds blend a lot more and a lot more often. Both more blend and more frequent blend than we've seen in the last 5 years that I've been, officially kind of working here at Strangeworks. And so, what does it mean? Yeah, there you will need some new tools, tools to manage, tools to inference, tools to data. You'll need new tools because quantum computers don't have memory. So
Yep.
you won't be taking a massive data lake and putting it on a quantum computer anytime soon.
Yeah.
So you have to take some sample of data. Well, how do you sample that data? And if you sample it different ways, is it get different results, right? So there's a huge greenfield opportunity for companies and individuals in machine learning to start looking into moving into kind of quantum machine learning. And there's a ton of opportunities to create new solutions, that new algorithms. There's a ton of opportunity. I mean, it's a wide open ocean.
Mm.
I think that quantum machine learning will be one of the first areas that you start seeing the more proofs of advantage, more usage, more stuff. And I think as the closer we get to a general purpose quantum computer, the more that will happen. But remember, these machines still don't have memory, right? We're still
Yeah.
running, single things to single qubits, be it a laser, wire, whatever. There's
Yeah.
all manner of things that to be solved. But if you're on the software side, quantum machine learning is the on ramp into quantum computing. It's my opinion. If you know enough
Mm.
about machine learning, that's your on ramp. It doesn't make it easy. If you're debugging it and you have a problem, and the problems with, you're writing something for security and you're doing teleportation, and you're like, okay, if you don't understand that, I mean, remember the early days of being a computer scientist, a developer, if you will, way back in the day, you had to be an electrical engineer because you had to understand the flow of electricity between the gates.
Yep.
Fast forward to 2023,
Yeah.
if you don't understand the physics,
It,
you know,
yeah.
you could
Even
be
you know
lost.
back in the day, like even 10 years ago, 20 years ago, machine learning engineers and data scientists had to worry about building the infrastructure before they can solve the problems. Not anymore, right? You've created a level of abstraction.
That's right.
And this is
That's
where
right.
like companies like Strangeworks, where your company, you guys can you're assuming you're creating that abstraction for more and more people to get into the fold and participate in this revolution as well, right?
Absolutely. Absolutely.
um, awesome, very cool. And I do we're kind of coming up on the time here. uh, any set of resources, and maybe you can just do this offline with me, right? Set of resources that
I've got to say, no, I got to say, I'm happy to say that we have recently contributed to an effort with the World Bank and the Linux Foundation that is a Linux Foundation training on quantum computing. Okay.
amazing.
And so you can add that to your show notes. Just go to Linux Foundation training section. I think it's featured, or you can Google Linux Foundation quantum training.
Yep.
That is a free course for people to take. It will
Awesome.
take you through the basics of the technology, a little bit of history, how it's being used, all those things. Stack Overflow, if you're a developer, we helped found quantumcomputing.stackexchange.com.
Got it.
Still a lot of people on there. Great place to get questions answered. Obviously, everyone for Christmas should buy a copy of Quantum Computing for Babies. I would be remiss not to say that. But in addition to the Linux Foundation and the Stack Overflow, we will be releasing tools to build tools on and everything, and the next version of our platform on November 30th. And so strangeworks.com is going to be a really good place to come because you will be able to do quantum computing without having to have some big monthly contract or have to have some access to a machine. And there'll be a dozen ways for you to get access and do stuff, because I do think that creativity and play is super, super important in science,
Yeah,
especially in computer science and quantum computing.
that's awesome. Whirly, this has been such a blast. Where can the viewers and listeners get in touch with you? Where can they find you on the internet?
I'm Whirly everywhere on Twitter and everywhere else, even OnlyFans. But just where can they find me? You know, uh, Go quantum at strangeworks.com. Always a good email address to use. Because if you email me, it could be months before I reply. You don't want that.
Yeah, I know
But
that.
but Twitter, Facebook, everywhere. It's real easy to find me. It's becoming harder for me to get back to people, which makes me feel really horrible. But I'm working on that and a system for hopefully making that better as we get into 2023.
You're a busy guy changing the world, and I really do appreciate you making the time to be here and talk to this audience, and also to to our relationship and the time that you make for me as well. So thank you so much.
Well,
Um,
thank you for your patience, because speaking of getting hard to get a hold of, I believe I had to reschedule you several times, and I apologize for everyone.
no,
It's
no
been
worries, really.
horrible.
This was such a blast. Thank you so much, and I'm sure like this has definitely given a window into the world of quantum computing for most of the audience who are, if you're new into this and this is the way, go check out strangeworks.com. I'll add the resources in the show notes as well. But really, Thank you so much for taking the time. That was a blast.
Thank you for having me.
All right.
Appreciate you.
See you. Bye.